Hey guys, and welcome back to another video in this week's DearPiggy Basic Algorithms in Java tutorial. Wow guys, that was actually my last time saying that because this is our last video in Basic Algorithms in Java. So that actually makes me kind of sad, but let's make it a good one. Okay, so in the last video, we talked about the idea of selection sort, and we actually did not discuss how much maple syrup is okay on waffles. So it looks like that is a topic we need to address today. So yes, and then we talked about the idea behind selection sort, which is essentially taking our array and splitting it into sorted and unsorted parts. That way, then we can sort the unsorted part, and we keep on bringing the minimum values over to the front of our unsorted array, and we keep on doing that until everything is sorted. Right, so that is the concept behind selection sort. Let's go ahead and put it into code. So the first part that I want to do is I want to turn our selection sort into a function. I think it's always important to put these things into functions so that we can use them over and over quite easily, right? So a couple of things that we have to do first when we create our function, we need to take in an array as a parameter. Now, one thing that I've noticed is a lot of us still get confused sometimes about creating our array. And actually, I just realized I might have done this wrong because it's not int array brackets. I'm pretty darn sure it's int brackets array. So that was my bad. But yeah, so we're going to take in an array as a parameter, and it's important to remember that whatever you call your array here, the name has to remain constant. So if you were to say the j index of the array, then you have to use arrj. You cannot just put array index j because those don't match. Now, if you were to spell out the entire word, you could then use array. We'll talk more about this when we actually get to it. We're going to create an n, which is just the length of the array that we will be using later on. Then we're going to have our for loop, and the for loop, we'll talk about what that does in a second. So now that I've looked at this, I've actually started to get unsure. So I guess we're just going to have to try and see. I need to start touching up my basic fundamental concepts, guys. So remember, every time you create a function, it needs to be outside of your main function, but still in your main class. So public static void selection sort, and then take in an integer array. Let's call it array this time so you guys get to see it. We're going to set int n to be the length of the array, and then I'm going to create my for loop. For int I is equal to 0, I is less than n minus 1, I plus plus. Alrighty, let's talk about what this means. So essentially, what we're doing here is in our array, remember we have the sorted and unsorted, and so each time the boundary, how we choose what the unsorted array is we move the boundary over by 1, right? So essentially this for loop over here is moving the boundary of the unsorted array, right? And since we do I plus plus because the boundary technically gets less, so the boundary is moving up in the index value, it might take a little while to wrap your head around that. But since our unsorted array is becoming smaller and smaller, that means the beginning of the unsorted array, the index value is getting bigger. So we're doing I plus plus. And it starts from 0 because our first unsorted array should be the entire array, right? So like what I wrote here, the for loop changes the boundary of the array each time through, so we have a smaller unsorted array each time, or basically a higher index starting value, right? That makes more sense, I think. So yeah, we understand what we did here. I think I should probably add a comment in here. First for loop is going to be change boundary of unsorted. I think I spelled boundary wrong. Boundary of unsorted array. All right, so now that we have our first for loop done, let's move on to this next part. Whew. So this next part is where we start introducing a little bit more stuff. So the whole purpose of this next part is to find the minimum value in your unsorted array. Because remember, when we're in this array, we need to find the smallest number in that unsorted array. Well, that is the step that we're going to be working on in this first part. In the second part, we need to find the smallest value. So we're going to set an integer, and that's going to be the minimum index. I think from now on, I'm just going to call it minimum because we want it to be the minimum number. We are going to set this to I first. However, you're going to see that in this logic here, it is slightly different because you're going to say for int j is equal to I plus 1. Why do we need int j to be I plus 1? Because we don't need to compare the minimum index to itself. We want to compare it to the number coming after. So as long as j is less than the length of the array, then j keeps on increasing because we want to keep testing out all those values. If the value at index j is less than the value at the minimum index, then we're going to have a new minimum index. Does this make sense here, guys? We have a minimum index set to a value, and we keep on comparing it to other values. As soon as we find out that there is a smaller value, we replace the minimum index to a new index that has that smaller value. It's going to take a little bit to understand it, but let's go ahead and put it into code. So first, we're going to say, sorry, my bad, int min, I'm still going to call it min index because I want you guys to differentiate that this is the index number, not the value. So is equal to I. We have to set it to I first. Then we're going to start testing all the numbers coming afterwards to see what the smallest number is. For int j is equal to I plus 1, because we can't have it be exactly I, because we don't need it to be equal to itself the first time. We just want it to keep on getting bigger and bigger. J needs to be less than the length of the array, but it can be the final number in the array. This is why some people get confused, because usually we always have it be less than the length of the array minus 1. But in this case, the smallest index value could be the last number in our array. So it works. J plus plus. All right. So what does this number do after we do that? If. And so we only change the index, the minimum index, if the value is smaller. So only in the case when array j ends up being less than array of min index, only, whoa, what happened over there? That should not have happened. Only when this happens do we need to set the minimum index. Oh my goodness, that is so frustrating. Every time I do that, it brings it down to the line below. Only then will we need to set our min index to j. So I think this makes sense, but then again, I've been staring at these things for a while now, so I can't really say. But essentially over here, we are testing all numbers, and if we find a smaller value, replace the min index. Hopefully that makes sense, right? So essentially, we start off with a starter index that is going to be our minimum index. We test all the other index values with this minimum index. As soon as we find a number that is smaller, we replace it. And that keeps going until we've tested all of the other numbers in the unsorted array. So check number 2 for our second for loop. Second for loop. So first for loop changes the boundaries. Second for loop tests all numbers for the smallest value that will replace the minimum index if there is. Last part. We remember saying, so far we have changed the boundary of the array. We've also tested and found the smallest value. The last step is to switch the smallest value out with our first number, right? There's always that step. Switch your smallest minimum value out with the first number in your unsorted array. So like 1 would switch with 6, 2 would switch with 3, 3 would switch with 7, 6 would switch with 7, and then the last one would switch with whatever is going on over there, right? So that is what we want to do, switch out the numbers. So back to something that we've been talking about for a while back. we need to switch the values using the triangular sort method that we talked about in our bubble sort. Remember bubble sort, guys? Well, it's coming back. Okay, so essentially what we want to do is we have a temp. So let me go ahead and go back to our whiteboard. Should I erase this? I really want to erase this, but at the same time, I feel bad. So let me just move it over. All right, so we have our temp and floating at the top. Then we have our number A and our number B. So the first step is to bring our A over to temp. So we set temp equal to A. I'm reviewing our triangular motion. Again, if you don't understand this, go back and watch the video from Bubble Sort that talks about the triangular sort method. Once we set temp to A, this first box is now empty, so we bring B over. So we say the A box is equal to B, and then finally this box is empty, so we bring the temp value down. But since the temp value is A, we have B is equal to temp, but temp, remember, is technically A. So you end up with your switched values looking like BA. So this was our triangular sort method. And so this is what we're going to write in code for our last step. We're going to switch our minimum index out with the current array index I. Why do we choose array index I? Because array index I is the boundary of our unsorted array. And it just so happens to be that the boundary of our unsorted array is the first value in the unsorted array, right? So perfect, everything worked out perfectly. The boundary is the first value. So that's exactly what we're going to use to do it. Let's go ahead and try it out. I feel like what I need to do, I think this would make more sense if I, not the highlighter, the eraser. So right now, currently, we're going to have, we have our I and we have our minimum index value. We want to switch it so it looks like minimum index value and I. So how are we going to do that? Just like what I did down here, remember the for loops might get confusing, but what you need to do is still be inside the big for loop, but get outside of your small for loop. So you're going to say int temp is equal to, and you're going to set it equal to your I. So you're going to say array I. And then I feel like this tab is doing it wrong. Otherwise, it wouldn't keep on getting mad at me. Nope, the tabs are right. Okay, hold on. Oh, I just realized it's not I. My bad, guys. It's actually minimum index. My mistake, silly mistakes. So then we're going to say array minimum index is equal to array I, and then array I is equal to temp. All right, so let's come out and let's take a look at this really quickly. So we have int temp is equal to array minimum index is equal to array I is equal to temp. So this is essentially what we did. We just flipped the order. Instead of bringing the first value up to temp, we brought the second value up to temp. So we can erase this and rewrite it really quickly. It's good to do this practice sometimes so that we truly understand how the triangular sort works, right? So we brought M up to temp. So we have temp is equal to M. So now this part is empty. So we bring I over. So then we say M is equal to I. Now keep in mind, this is pseudocode, not real code. And we bring the temp, which was the M. So then we say I is equal to temp. But keep in mind, temp is actually M. And so we have actually sorted it, right? So in my comment here, I'm going to say use triangular sort to swap first value and min value. Okay, easy peasy, simple as that, right, guys? Temp is minimum index is I is temp. Again, if you did not understand that, go back and look at this part that I just talked about a little closer. So that is a lot, and I'm not even personally sure myself it's going to work all the first try. But before we try that out, we have to test run our code. So the last part is to create our array in the main function, run the function, and print out the sorted function. So we're going to go into our main function and say int array is equal to. So what are some, here is the time where we decide our ounces of maple syrup, right? So we're going to say, some people are crazy and they just have to really dump an entire bottle on there, so 12 ounces. Some people are normal like me and they go with maybe like 3 ounces. Some people are still on the psycho side but not quite crazy yet. Some people are just a tiny bit, and some people just, go absolutely insanely crazy and drown themselves in the maple syrup. So that is our array. Most importantly, we've written our function. We need to actually run our function though. Grapple it with the annoying parts of my life. This really drives me crazy sometimes. Okay, so we're going to run our function and say selection sort, and then pass in array as our array. And then finally, we're going to print out our sorted array. And say for int x in our array, go ahead and system.out.println x. This is a for each loop. All right, the time has come. Time to see how well our code works. I cannot guarantee it's going to work on our first try, and it did not work on our first try because we used brackets instead of curly braces. How stupid was that? Probably a typo on my end. All right, there we go. We changed it, so now it's curly braces. Let's see if there are any other errors that we get here. One error, number 29. Oh, all right, so this is probably a part where I mixed up my curly braces. So this curly brace does not have a twin. So let's go ahead and find a twin for our curly braces, because obviously one of our curly braces is missing the other. All right, so how we find out whether or not our thing is missing a twin is you go ahead and click on all your curly braces. The beginning of this one matches with this one. The beginning of this one, however, matches with the very last one, meaning that our very big one for our entire main class does not have a match. Poor thing. So we're going to add an end curly brace over here, and you're going to realize that now it matches with this bottom one. This one's going to match with this one. This one matches with this one, and boom, we are perfect. So let's run our code. Cross your fingers and hope this one's going to work. So it should bring this out array completely sorted, and yes, it does. It sorts our maple syrup in ounces from least to greatest, 1, 3, 8, 12, and this crazy psycho number. I don't know why you would put that much maple syrup on your pancake. But yeah, so this is our code for selection sort. I feel like I've talked for long enough now, so I'm going to stop talking. But I just do have to say, guys, I enjoyed this course so much with you guys, and I had so much fun. I hope you guys understood these topics. These were hard high school AP and college level concepts. So I really hope you guys understood them. If you have any questions, feel free to email me as always. And I hope you guys enjoyed this course, and we'll come back as always for more. So I will see you guys later. Bye, guys.